spectrum of design and analysis of rigid pavements in 50 minutes. I spent 15 weeks teaching an undergraduate course and a graduate course in this area. But hopefully I can give you a brief overview, and if there is more interest, we can always have a conversation later on. So, okay, trying to do page down. Screen is stuck. Let's see. Okay, I'm not sure why in the full screen mode I was not able to page down. Hopefully you can see my the slides. So I did a quick Google search on the highway network in India, and based on some statistics, I found that India has approximately 143,000 kilometers of national highway, and 2.7% of those national highways carry close to 40% of the traffic. That is based on 2013 data. So it's very clear that the performance of pavements, whether it is concrete pavements or asphalt pavements, is very critical to the economic lifeline of any country. And generally speaking, the transportation network, whether it is by air, by land, or by water, are very critical to the economic survival of any country. And therefore, the maintenance of that network is very critical. And large investments are made in making sure that this network continues to perform well over time. So clearly it is important for India or for any country to pay attention to their surface transportation network, especially in this case, their pavements. So there are several types of concrete pavements. We are not going to be talking about all of these. We'll talk about a few of these, but I thought it is important that at least I list the types of concrete pavements that you may come across. There is a family of concrete pavements referred to as jointed concrete pavements. And within the jointed concrete pavements, you have jointed plain concrete pavements and jointed reinforced concrete pavements. Then there is a family of concrete pavements called continuously reinforced concrete pavements, and these pavements don't have any joints in them. Then, of course, you can repair an existing asphalt pavement or an existing concrete pavement using overlays, that is placing another layer of concrete on top of an existing pavement. And then there are some special classes of pavements called roller compacted concrete that look very much like asphalt pavements. You have pervious concrete pavements that are used in parking lots, sidewalks, but very rarely used in urban applications because of structural limitations. So what does a concrete pavement look like? If I was to look at a cross-section of a concrete pavement, the bottommost layer would be the natural bedrock, if there is. Then on top of that bedrock, you would have the natural soil, which we refer to as subgrade or roadbed. And then on top of the natural subgrade or roadbed, that is the compacted or treated subgrade or the roadbed, which is classic, and you characterize that by its resilient modulus or the modulus of subgrade reaction. So that is measures the stiffness or the strength of the compacted roadbed. Then the next layer, which is the engineered layer, is the subbase. Now the subbase can be unbound, which would be a granular subbase, or it could be bound with stabilizing the subbase to further improve its resilient modulus. And it can be stabilize using fly ash, cement, lime. There are many different ways by which you can stabilize the subbase to increase its resilient modulus or the elastic modulus of the material. The next layer, which is immediately above the subbase, is the aggregate base. And again, this material can be both bound or unbound. And again, if you are going to stabilize the base, you're essentially doing it for structural capacity and improved load carrying capacity. And then, of course, on top of the bound or unbound aggregate base is the Portland cement concrete slab, which carries most of the load and the stress. And that is also characterized minimally by its elastic modulus. And then, of course, there is a designed slab thickness. And then, of course, is the axle load that is placed on this cross section. Now, there are multiple sources of stresses in a concrete pavement. One, of course, is shown here in the slide, is the load stress due to trucks. Another source of stress is the environment, both changes in temperature as well as changes in moisture induced environmental stresses in the concrete pavement. And the third kind of stress that is induced in a concrete pavement is the friction that exists at this interface between the Portland cement concrete slab and the aggregate base. Because concrete, as the temperature changes, when it becomes hot or when it becomes cold, the slab will tend to either expand or contract. And when the slab tries to expand and contract, the friction at this interface opposes that contraction or expansion. And because of these opposing nature of forces, there is stress that is created at this interface. So all these three stresses exist in a concrete pavement at some magnitude, at some level of, at some stress level. Okay, so when you're designing a concrete pavement, you have to design the pavement in such a way that it counters all these three stress types: the load stress, the environmental stress, as well as this interface frictional stress. I think I would request the participants to mute their mic. So again, this is not able to advance this. Okay. So let's look at each of these layers independently. So why do we have a base layer or a sub-base layer in under a concrete pavement? One simple reason is for uniformity of support. And the more uniform the support, the more smoother is going to be the ride on the concrete pavement. That is one reason why we have a base and a sub-base under the concrete slab. The second reason is for drainage purposes. Whenever there is precipitation, some of the water will run off because of the natural slopes, but a lot of the water will permeate through the concrete into the underlying layers. And we can control the drainage under the slab through the gradation or the particle size distribution of the aggregates, and force the water to drain away from the concrete pavement, because what you don't want is water to accumulate under the slab. Because if water accumulates under the slab, the base and the subbase and the roadbed will start losing their strength, and you can get shear failures, you can get pumping, which can then result in the faulting of the joints, and then the uniformity and the continuity of the support is lost. The base and the subbase also provide a good, smooth construction platform for the construction traffic to ride over the base and the subbase while the construction is going on. Places where there is a lot of freezing and thawing of the water in the soils, the base and the subbase prevent frost action from taking place. And then the base and the subbase are also protecting the subgrade from shrinking and swelling because water gets in and the soils can swell. When that water dries, the soils can shrink. So the base and the subbase play a very critical role in the construction and the performance of concrete pavements. So here are some pictures showing you different kinds of bases. So this first picture on the left shows you what an aggregate or an unbound granular base looks like. And the granular base or the unbound base can be made out of crushed or natural aggregates, recycled aggregates. So this material is placed and then it is compacted to the right density. Another kind of base is a stabilized base or a bound base, as I had said before. And there are different kinds of bound bases. You can have a cement-treated base. That is, the aggregate is mixed with low percentages or low amounts of Portland cement. You can have a lean concrete base, which is weak Portland cement concrete. You can stabilize the concrete. You can stabilize the base with liquid asphalt. So that is known as an asphalt concrete base or an asphalt stabilized base. All these bases will have a much higher elastic modulus or resilient modulus as compared to the aggregate or granular base. Okay, and of course, the stabilized bases provide more structural capacity to the concrete pavement as compared to an aggregate or a granular base. The third kind of base that can be used is for drainage purposes is known as an open graded drainage course. So in this case, you are creating large voids between the aggregate particles such that when water gets through the concrete pavement, this layer serves as a drainage layer and makes sure that the water leaves the concrete pavement and does not accumulate under the concrete pavement and cause other structural problems. So these are examples of different bases that can be used under the concrete pavement to make sure the pavement has adequate performance and can last its design life. Another very critical component of a concrete pavement are the joints. And if the joints are designed properly and constructed properly, the concrete pavements will last a long, long time. Most of the failures in a concrete pavement begin at a joint. And if the joints are not properly designed and constructed, those failures can shorten the design life of or the design life and the performance life of a concrete pavement. So what this picture is showing you, this is called a transverse joint, which means this is orthogonal or 90 degrees to the direction of traffic. This is called a longitudinal joint, which means that joint is in parallel to the direction of traffic. This picture that you see is that of a dowel bars, and dowel bars are always placed along a transverse joint to transfer deflection from one slab to the other slab across the joint. Because if there is no mechanism to transfer deflection from one side of the slab to the other side of the slab, then of course you can have differential settlement between the slabs, which we call joint faulting. So these dowel bars that are usually, these are metallic dowel bars that have to be designed and placed in such a way that deflections can be transferred from the loaded slab to the unloaded slab. These bars that you see that are placed along the longitudinal joints are known as tie bars. And the function of the tie bar is to connect this lane with this lane so that there is no differential movement between the lanes. All these components are very critical to the success or the failure of a concrete pavement. So there are many differences between dowel bars and tie bars. The first difference is that the tie bars are smooth as compared to the the dowel bars are absolutely smooth. The surface is smooth, whereas a tie bar just looks like a reinforcing steel, so the surface is ribbed or corrugated. That allows the concrete to bond to the tie bar. So that is the first big difference between the tie bar and a dowel bar, is that the dowel bar is smooth, the tie bar is rough. The second difference is that dowel bars are traditionally much larger in diameter as compared to a tie bar. So dowel bars are much bigger. The third difference is that the dowel bars are designed to transfer deflection across the transverse joints, whereas a tie bar is designed to hold the lanes together along the longitudinal direction. So you cannot interchange. You cannot take a dowel bar and put it in the longitudinal joint, and you cannot take a tie bar and put it in the transverse joint. That will not work, because the functions and the physical characteristics of these materials are quite different, or of these two bars are quite different. So you cannot interchange a dowel bar with a tie bar and hope to get the same performance, because you will not, because they're designed to carry out specific specific actions in a concrete pavement. So that needs to be the differences between these two need to be noted. There are different kinds of joints in a concrete pavement. The three most critical joints are the contraction joint, the expansion joint, and the construction joint. The contraction joints are transverse joints that are usually placed 3.5 to 4.5 meters on center, so that is usually the spacing. And the purpose of the contraction joint is to make sure that when the slab expands and contracts, it is able to absorb that movement. Because if the slab had no contraction joint and the slab moved back and forth, eventually there will be a transverse crack, because the slab needs to release the stress built up due to the expansion and the contraction. So the contraction joint, which is placed in the transverse direction, is designed to absorb the movements due to environmental stresses, due to the environmental move that the slab goes through movement because of the changes in temperature. So that is very critical. On the other hand, a construction joint is usually placed at the end of the day when the construction is over for that day, because you have to have a smooth transition between one day's construction and the construction that happens the following day. So construction joints are exactly what they say, are joints that mark the end of the day's construction. Expansion joints are usually placed between dissimilar structures. So when the pavement comes in contact with a bridge, then you want to isolate the movement of the bridge from the movement of the pavement, because the bridge elements expand and contract at different rates as compared to the concrete pavement, because bridges have soil in them, steel in them, concrete in them. So their coefficients of thermal expansions of all these materials are quite different from a concrete pavement. And if you don't isolate the movements of these structures from each other, you can cause failure in both those structures. So an expansion joint is placed predominantly to separate the movements of dissimilar structures, for example, bridges and pavements. So with that introduction, let's look at the different types of concrete pavements that are constructed around the world, and look at the characteristics of these different pavement types. So the first one, as I mentioned to you, is called a jointed plane concrete pavement. And the acronym for that is JPCP, jointed plane concrete pavement. A typical cross section would have a roadbed, a subbase, a base, and then of course the driving surface, which would be Portland cement concrete. What you're seeing in these two pictures on the right are construction projects for jointed plane concrete pavements. And so what you're seeing here are the dowel bars that are being placed, that have been placed, and these would be the transverse joints, the contraction joints that will be constructed. And then, of course, along the longitudinal joints, you can see the tie bars that will connect this newly constructed lane with this lane, which is ready to be constructed. The typical joint spacing, as I had mentioned, that is the distance, the center to center distance between this row of dowel bars and this row of dowel bars is usually between, as I said here, 3.6 to 4.9 meters, or 12 to 16 feet. This is a typical characteristic of a jointed plane concrete, that the transverse joint spacing is very close to each other. And this is a plan view of what a jointed plane concrete pavement would look like. So these are two lanes, a shoulder. These are the longitudinal joints. And along these longitudinal joints, what and these are the transverse joints. And these solid lines that you see are the dowel bars that allow the transfer of deflection from one slab to the other slab. So this gives you a plan view. This gives you a plan view of what a jointed plane concrete pavement would look like. There are several applications of jointed plane concrete pavements. Parking lots, airports, highways, port container loading docks. Jointed plane concrete pavements can be universally be applied to any kind of application where concrete pavements are constructed. Okay. So it's a very versatile pavement, or a kind of concrete pavement that can be applied pretty much in any situation. There are several design procedures, and there is, of course, an Indian standard that is used to design concrete pavements, that lays out the design procedure. It lays out the specifications required for the design of a concrete pavement. But there are other design methodologies that are in existence, that can be used for the design of concrete pavements. And these are just some examples of design softwares and design models that are available for the design of jointed plane concrete pavements. Another family of jointed concrete pavements is called the jointed reinforced concrete pavement, or JRCP. And the big difference between JRCP and JPCP is that, well, there are two differences. One is the joint spacing. The joint spacing in JRCP is much longer than the joint spacing in JPCP. The joint spacing can be anywhere from 9 to 10 meters to 20 meters. So it's a much longer joint spacing as compared to as compared to the 3.5 to 5 meter joint spacing that I mentioned in jointed plain concrete pavement. So that is one big difference. The second difference is because it is called a jointed reinforced concrete pavement, there is a reinforcement mesh in the body of the concrete. And the purpose of that reinforcement mesh is not for structural purposes. It is not structural steel. It is steel to combat, to counter the temperature stresses. The temperature stresses that can cause expansion and contraction in a concrete pavement. And the wire mesh or the steel mesh helps in bridging the microcracks that can take place in a concrete pavement due to the expansion and the contraction. So that's another major difference between a jointed reinforced concrete pavement and a jointed plain concrete pavement. However, in the US, we have stopped using jointed reinforced concrete pavements, I would say, over the last 10 or 15 years. So no new jointed reinforced concrete pavements are being constructed in the United States. So the only two types of pavements that are constructed in the US are the jointed plain concrete pavements and the continuously reinforced concrete pavements that I'll talk about in the next slide. But again, just for the sake of completeness, this shows you a plan view of a jointed reinforced concrete pavement. Again, this is a transverse joint with dowel bars in them. This is a longitudinal joint with tie bars in them, and notice that the transverse joints are spaced much further apart as compared to a jointed plain concrete pavement. And there is this welded wire mesh or reinforcing steel, which is not structural. The purpose of the steel is to only counter environmental stresses due to the expansion and contraction of a concrete pavement. The third category is referred to as continuously reinforced concrete pavements. And the biggest difference between continuously reinforced concrete pavements and jointed concrete pavements is that there are no contraction joints in a continuously reinforced concrete pavement, and that is why it is called a continuous concrete pavement. The other difference, the other major difference is that is steel, structural steel, both in the longitudinal as well as the transverse direction in the concrete slab. And this steel is placed to enhance, improve the load carrying capacity of the concrete pavement. So clearly, this steel is structural steel that is placed in a continuously reinforced concrete pavement. So what you're seeing here are pictures. As you can see in the bottom left and right pictures, you can see the structural steel, and then in the middle picture, you're seeing the placement of the concrete. So what happens is when you don't have joints in a concrete pavement, you have to get shrinkage cracks because concrete by nature will shrink. And when shrinkage takes place in fresh concrete, that is cracking. So a typical characteristic of a continuously reinforced concrete pavement is what you see here in the bottom left are these transverse cracks that are shrinkage cracks. Now, the difference between a shrinkage crack and a regular transverse crack is that a shrinkage crack is a non-structural crack. It does not take away from the load carrying capacity of the pavement. That is one difference. The second difference is that a shrinkage crack is only a surface crack. The crack does not propagate all the way through the depth of the slab. Whereas a regular transverse crack can become a structural crack and has the capacity to propagate all the way through the depth of the concrete slab. So even though you see cracking on the surface of a continuously reinforced concrete pavement, it does not mean that the pavement has failed, because these cracks are simply shrinkage cracks that do not take away from the load carrying capacity of the concrete pavement. Also, the steel that you see here in the top two pictures plays a role in holding these cracks together. They make sure, the steel makes sure that none of these cracks open up. So the crack widths are very tight. And when the crack widths are very tight, there is no loss of load transfer, or there is no structural problem to the concrete pavement. Generally speaking, the crack spacing that you see here is 1 to 2 meters. And the crack spacing is a function of the percentage of steel. Higher the steel, the closer is going to be the crack spacing, because there is more restraint. The depth of the steel and the thermal and the coefficient of thermal expansion of the concrete. These three parameters, the depth of the steel, the percentage of the steel, and the coefficient of thermal expansion of the concrete, determine how closely spaced or how far apart are these shrinkage cracks. Like I said, for good design, 1 to 2 meters of crack spacing, of the shrinkage crack spacing, is considered acceptable for the design and the performance of a continuously reinforced concrete pavement. So here are some pictures. I suspect you've heard of Chicago, and a lot of the concrete pavements in Chicago are continuously reinforced concrete pavements. The picture on the top left is a 50-year design of a continuously reinforced concrete pavement in the state of California. And you can see these transverse cracks, but these are all shrinkage cracks. So even though you see a crack, that does not mean that the pavement has failed. These are just shrinkage, superficial shrinkage cracks, and the pavement still has the structural capacity to carry load. Again, these are some references that I have used and are available actually free online. These are research reports that talk about the design of continuously reinforced concrete pavements. So the one good thing is, in the US, that most of the research that happens on pavements, whether it is concrete pavements or asphalt pavements, is funded by either the state government or by the federal government. And therefore, all the products that come out of it, especially the research reports, as you can see, the images of the cover pages, are available freely for anyone to review and refer, because all this research was done on tax-paying dollars. And when research is done on tax dollars, the products that result from this research should be freely available to the citizens. So therefore, that is very advantageous, that even though you may not have done the research, you can freely access research done by others, and learn from it. Learn from it the positive elements of the research, as well as the mistakes that were made in the research. So again, this just shows you some of the reports that are available freely online for you to download and read and review and learn about it if you are not familiar with some of these technologies. Another kind of concrete pavement that is slowly finding prominence is called roller compacted concrete pavements, or RCCP. And I want to draw your attention on the bottom left picture here. This is what the surface of Portland cement concrete looks like. And this is the surface of a hot mix asphalt or an asphalt pavement looks like. And in the middle is a picture of the roller compacted concrete surface. The roller compacted concrete pavement, except its color, which is grayish in color, has all the characteristics of an asphalt pavement. It is more like an asphalt pavement and less like a concrete pavement. And the picture you see on the top left shows how a roller compacted concrete is placed. It is placed using an asphalt paver. So the same equipment that one uses to construct an asphalt pavement is used to place the roller compacted concrete. And then after the pavement has been placed, as you can see here, there's a roller, and hence the roller compacted. A heavy roller is used to compact the pavement for strength purposes. So if you are familiar with the construction of asphalt pavements, that is how asphalt pavements are constructed and rolled to make sure that it has adequate strength. Some unique characteristics of roller compacted concrete is, and this is the picture on the top right, shows the mixed design comparisons between traditional concrete, which is the light blue bars, and roller compacted concrete, which are the dark blue bars. So the roller compacted concrete mixes have less amount of cement, less amount of coarse aggregate, but larger amount of fine aggregate, which is what hot mix asphalt has. And the bottom right picture shows you the gradation distribution of the aggregates in roller compacted concrete as compared to hot mix asphalt concrete. And you will notice that the gradations are very similar for roller compacted concrete and hot mix asphalt concrete. So roller compacted concrete is also known as zero slump concrete. So the concrete, because of the low cement and low water contents, does not have a lot of flowability. And therefore, the placement is done using an asphalt paver. Generally speaking, roller compacted concrete pavements are not used for interstate or highway applications. They're used in places where there is low volume traffic or slow speeds of traffic. So parking lots could be constructed using a roller compacted concrete. Loading docks can be used, can be constructed with roller compacted concrete because you have lower speeds. So the application of roller compacted concrete is not as widespread as jointed concrete pavements or continuously reinforced concrete pavements, but it does have applications in low volume, low speed areas. So it does have applications. These are pictures just showing you the construction of roller compacted concrete, and you notice in the bottom right picture that this is an instrument called a nuclear gauge or a nuclear densometer, that after the rolling has happened, you can use this instrument to measure the percentage of compaction that has taken place due to this rolling operation. Just as you would do for asphalt concrete or a compacted base or a subbase or roadbed, you do have to reach a certain level of compaction before the pavement can be opened to traffic. So there are many differences between there are many differences. I just saw a message to put this in slideshow. The problem is Okay, well, maybe it works now. Um, uh, that in a rigid pavement or a concrete pavement that we've been talking about so far, there is a concrete layer, then there is the base, the subbase, and the roadbed. But the way a concrete pavement or a rigid pavement is designed, it's designed in such a way that 95% of the deflection and the stresses are carried by the slab. And what I mean by the slab is this Portland cement concrete slab. And very little of those stresses and deflections go into the foundation layers, that is the base, the subbase, and the roadbed. If you contrast that with asphalt pavements or flexible pavements, the design philosophy is very different. That the deflection and the stresses are transmitted through all the layers of the pavement. That is, the base, the subbase, and the roadbed play a critical role in carrying the stresses and the deflections and the strains such that there is good performance of the flexible pavement. So this is a fundamental difference between how a rigid pavement carries load and distributes load, and how a flexible pavement carries load and distributes load. So it is important to understand that the design philosophy of a rigid pavement or a concrete pavement is very different from the design philosophy of a flexible pavement or an asphalt pavement. The failure mechanisms for rigid pavements are quite different than the failure mechanisms of a flexible pavement. Okay. And the terms rigid and flexible have nothing to do with the color of the pavement, that is gray versus black. It has to do with the stiffness of the different layers and the moduli of the different layers that determine whether the system is going to behave like a rigid pavement or if a system is going to behave like a flexible pavement. Because common mistakes are made that if the surface is black in color, then it must be a flexible pavement. And if the surface is gray in color, then it must be a rigid pavement. Many times that is not true. The rigidity and the flexibility is a function of the stiffness of the materials and how the system behaves. So again, I wanted to make sure that you see that difference. I'll quickly talk about this last type of pavement and then leave about 15 minutes for questions and answers. Another kind of pavement that has applications not on the highway system or the interstate system, but in low volume local roads is this pervious concrete, which is extremely drainable. It has large voids in the aggregate structure, 15 to 30% voids, very high permeability. This can be used in sidewalks, along sidewalks. It can be used in parking lots. It helps preventing runoff when you get heavy rain. You want to minimize the runoff water and contaminate the groundwater. So it has limited applications, but it has been used in a very limited way for low traffic applications, low volume traffic applications. So I thought I'll just share a picture of that with you. And here are some pictures of the use of pervious concrete. So as you can see, here's a parking lot, and then here's a sidewalk that is constructed. So this is a residential area, and you can so there is really no vehicular traffic. This is only foot traffic. This is another sidewalk. Again, only foot traffic, no vehicular traffic. Maybe a bicycle or two, but really no significant loads on this. So this is just really allowing water to drain and then drain away from the pavement. So independent of any pavement that you design, whether it is an asphalt pavement or concrete pavement, there are multiple goals of the design. The first two goals are that the pavement should provide a safe and a smooth ride to the motoring public. And these are referred to as functional design goals, because the function of a pavement is to provide safe and smooth ride. And the safety and the smoothness of the ride generally comes from good construction practices. And then, of course, there are the structural components and the material components, which are the durability of the material, the sustainability of the structure. That is, you have minimal interventions to repair the pavement, because every time a pavement needs to be repaired, then there is a lane closure. People have to take detours, so it lengthens the travel time. So you're spending more time in your vehicles. You are burning more petrol in the vehicles, or diesel. So every time that is construction, the user cost goes up. So if you can minimize the repairs of a pavement, and the way you minimize the repair of a pavement is by making sure that the pavement is structurally sound. So a good pavement design should result in a safe, smooth pavement that is durable, sustainable, and structurally sound. So good construction practices and good engineering practices can generally deliver a safe, smooth, durable, sustainable, and structurally sound pavement. Doesn't matter whether it is a concrete pavement or whether it is an asphalt pavement. These are just some of the references that I have used and some of these were shown as part of the as part of the presentation. So with that, I'll stop the presentation and see if there are any questions.
Yes, sir. Yes, sir. There are questions, sir. Can I ask the
Sure.
first one, sir?
Yes.
Yeah. Which software is available and suitable for design of rigid pavements and their joints?
So that is obviously in India. There has got the IS code, the Indian Standard Code, lays out a concrete pavement design procedure. So concrete pavement should be designed for the specification and codes for the region, because codes are written to reflect construction practices, load, the load profile of that region. So you cannot take a design software from one country and apply it to another country, because the models are different, and the environmental and the load considerations are quite different. Okay, so I would always warn people from blindly using software that does not apply to the conditions of that region. Okay, so that is a warning, and that should be considered before applying any software. So, but there are design procedures like the AASHTO, and you can of course read about that. And then, of course, in the US, now we are using this mechanistic empirical design procedure. And the software is not free. However, the design that's what I would say regarding software.
Okay, sir. The next one is, what are the reasons? Hello.
Yes.
What are the reasons for longitudinal cracking?
So longitudinal cracking can take place for a variety of reasons. One reason could be that the tie bars are not properly designed, or there are no tie bars. So if the tie bars are not properly designed, or if there is an absence of tie bars, then the lanes are free to move independently of each other. So that can be one reason. Another reason it could be, and this is usually if the longitudinal joint between the shoulder and the concrete pavement, sometimes you get shear failure. That is, and the soil below the pavement and below the shoulder fails in shear, and the pavement loses support, and you can get a longitudinal crack close to the longitudinal joint between the pavement and the shoulder. That's another place where I have seen longitudinal cracking. Um, Another reason, of course, is the thermal deformation of the slab due to temperature gradients, because the temperature gradient through the slab is not uniform. That is, during the daytime, the surface of the slab is hotter than the underside of the slab. So there is a positive temperature gradient and the slab is curled. At nighttime, the surface is cooler than the underside of the pavement, so you get an opposite or a negative gradient. And that negative gradient causes a negative curl. And the curling of the slabs produces temperature stresses, which can also result in both transverse and longitudinal cracking. So, there obviously there is not one reason why a pavement exhibits cracking. There are many, many reasons. And of course, investigations have to be done before reasons can be assigned as to why a pavement exhibited longitudinal cracking or exhibited transverse cracking.
Sir, next one is, concrete pavements are the most of the time noisy. Could you please quote any methods to minimize noise over CC pavements?
Right. So noise again is a function of construction. So as I had said in the early part of my presentation, that number one, smoothness and noise. So smoothness can be guaranteed through uniformity of support. So that allows some level of smoothness. Secondly, the paving operations have to be done in such a way that it ensures, or at least raises, the probability of a smooth ride. Noise again has to do with how well the joints are constructed, because one source of noise is the joint. Every time a tire rolls over a joint, there is noise. So the joints have to be constructed properly. And then, of course, the tining, the longitudinal tining that is done in a concrete pavement is done predominantly to absorb the noise. So longitudinal tining has to be done in an appropriate way, such that it can dampen and absorb the noise due to the tires rolling over the pavement. In many instances, diamond grinding is done. Diamond grinding is done to smoothen the surface of the pavement, but also then to reduce pavement noise. So these are, again, there is no way to design a smooth a quiet pavement. The reduction in noise really comes from construction practices.
The next one, sir, how dowel bar and tie bars are placed, as well how joints width and size are ensured. Yes,
Uh,
sir.
so, so dowel bars can be placed in two ways. I had shown you pictures where dowel bars were placed on baskets, and those baskets are placed prior to placing the concrete. Another way to place dowel bars is by using a mechanical implanter, or also known as a dowel bar inserter. So what that does is that once the concrete is placed, the dowels are placed from the surface, they're pushed into the wet concrete. Okay, so those are the two ways by which dowel bars are placed. Again, tie bars can also, while tie bars can be placed through an implanting method, uh, that is pushing the tie bars into the wet concrete, or holes are drilled on the side of the slab, and the tie bars are pushed inside the hole, and then when the new layer is placed, the two layers are then tied to each other because of the tie bars. So there are mechanical ways of placing and there are manual ways of placing both tie bars and dowel bars.
Next one is, sir, what is the maintenance cost of rigid pavement when compared to the flexible pavement?
Again, that is a function of so many things. It is a function of the cost of materials. It is a function of how often the pavement needs to be repaired. Um, so that's a question I don't think I can answer without it's a function of the region in which you're living and where these pavements are being constructed, and you have to do a life cycle cost analysis to figure out the cost of asphalt pavements versus concrete pavements, because it's such a local it's a function of the local characteristics of the materials and the cost. So that is difficult to answer in sort of in a black and white way by giving a rupee value or a dollar value.
So next one, sir. Hello.
Yes.
Next one is, what is the advantage of RCCP over flexible pavement?
There is no, again, it's not one or the other. RCCP, roller compacted concrete pavements, are typically not used for interstate systems. So flexible pavements, just like concrete pavements, are used on the interstate system. So RCC pavements can be used in sort of low volume, low speed applications, whereas flexible pavements are a lot more versatile, or asphalt pavements a lot more versatile in use. So it's the applications are different. It's not that one is better than the other. It's just in where they're applied.
Okay, sir. Next one is, mm, when seepage under pavement is considered disadvantage, how can we have permeable pavements? Hello,
So
sir.
permeable.
Yeah.
So all pavements. So once water gets into through the concrete pavement and goes into the permeable base or the OGDC, as one example I showed you, because of the cross slope, the water will move towards the edges of the pavement, and then you have to have a network of pipes, which we call edge drains, which collects this water and then removes the water and puts the water out into ditches. So that's how water is removed from under the pavement. The whole idea is not to allow water to pond or accumulate under the pavement. So the cross slope will allow the water to go to the edges or the sides. and then that water gets collected by edge drains, and then those edge drains will then empty out the water into drainage ditches. So that's how the drainage system works in concrete pavements or in asphalt pavements.
So next one is, sir, what is the maximum wheel load bar standard axle load considered for RC CRCP? Where CRCP are recommended?
So the wheel loads are whatever are mandated by the state or the region, right? So the axle loads, you have single axles, you have tandem axles, you have tridem axles. And then, of course, you have different configurations of combinations of these axles. So whatever are the legal load limits for that region or for that state are the ones that have to be considered for design. So there are multiple elements to traffic design or load design. One, of course, as you mentioned, are the axle loads. The second is the frequency with which those axle loads operate on that pavement, and then the volume, the total volume of the traffic, especially the truck traffic. So all those have to be taken into consideration in the analysis and the cross-sectional design of a concrete pavement, whether it is a jointed concrete pavement or a CRC. The axle loads are the same. It is a preference whether you have the capacity to construct a jointed concrete pavement or a continuously reinforced concrete pavements.
Next one is, sir, is it possible to provide a overlay on rigid pavements?
Of course, you can put a concrete pavement on top of a concrete pavement. That is called, you can have a bonded concrete overlay or an unbonded concrete overlay.
Next one, sir, is there a difference between asphalt pavement and bituminous pavement? Are both the same?
They're the same. There's just different ways of calling them, yeah, but they're basically flexible pavements, yes.
Is groundwater can recharge by using porous concrete pavements?
Yes, but again, porous concrete or pervious pavements are not suitable for interstate system or places where there are heavy loads. So it's really in sidewalks, and as I showed you pictures of parking lot sidewalks, again, that was just an example of another kind of pavement. But that has no application for the interstate or the highway system where you have large volumes of traffic and heavy traffic.
Next one, sir. What are the best plasticizers which can be used for the flexible pavements?
I'm not aware of using
Plasticizers.
plasticizers for flexible pavements. I mean, there are modifiers and polymer modifiers used to improve the PG grade of asphalt. The admixtures or plasticizers are generally terms that we use in concrete pavements, not in asphalt pavements.
Next one, sir. Which type of concrete pavement is most advantageous in Indian condition?
If you have good contractors, if contractors can produce a quality job, then both jointed concrete and CRC can be constructed. However, jointed concrete pavements are probably a little easier to construct than CRC. It's less complicated, but both pavement types can function well in Indian conditions.
Next one, sir. Can we use special concretes like fiber reinforced concrete in rigid pavement construction?
Yes, but again, you have to have a reason why you want to use fiberine, why you want to incorporate fibers in concrete. So yes, I mean, the short answer to the question is yes, you can use fibers, but every time you add an additional material to a pavement, it drives the cost up. So there has to be a compelling engineering reason as to why one would want to incorporate fibers in concrete.
Next one, sir. What grade of
So can we make that the last question, because it's I have another meeting to go to. So
okay. The last question, sir. What
Not changing.
what grade of concrete generally used in USA for concrete pavements?
So in the US, we measure concrete strength using cylinders, and I know in India cubes are used. So typical concrete strength, compressive strength of concrete is 30 to 35 megapascal, 28-day strength, which which is not normally used in paving grade concrete.
Okay, sir. I am giving mic to Murthy, sir. Murthy, sir.
Okay, thank you.
Murthy, sir, concluding remarks.
Okay, sir. Okay, thank you, Professor. Thank you very much, Neeraj Buch sir. I express and extend my deep sense of gratitude to you on behalf of our Swarnandra College of Engineering and Technology and our Civil Engineering Department, and on behalf of all the participants for your valuable and informative presentation, sir. I was very thankful to Dr. Ramesh Babu Garu, Secretary and Correspondent of Swarnandra College of Engineering and Technology, and S. Suresh Kumar Garu, principal of our college, for their immense support to conduct this program. I was thankful to Dr. Prasad, my colleague, Dr. Prasad sir, for his technical support and conducting and hosting all the sections in an excellent manner. I was thankful to my colleague, Mr. Venkatekrishna, for designing and coordinating for the program. And thanks to Mr. Satish and Rajiv, my colleagues, for circulation and other infrastructural work for the successful program. Thank you all the participants for your kind cooperation for closing this program in a smooth manner. And again, I am very thankful to our respected Neeraj Buch sir for kindly accepting our invitation despite his busy schedule and allotting his time for our session. Thank you very much, sir. Thank you all the participants. Now I hand over to Mr. Prasad for announcement. Neeraj Buch sir, thank you, sir. Thank you very much,
Thank
sir.
you.
Thank you, sir.
Thank you very much, sir. Thank you from
Thank
our
you.
side. Thank you, sir.
Thank
So, announcement to the participants. The feedback form will be circulated to your respective emails tomorrow. After submitting the feedback form, you will get your certificates. Thank you very much for all.
Prasad,
Sir.
Prasad,
Sir.
Prasad, sir.
Yeah.
You told them to that certificate is signed with the sir. That's why late.
Yeah, because our resource person signature is also on the certificates. That's why we are waiting for his signature. So that's why please give 1 day for us. So within 1 day we will get the signature and we will put the signature of our resource person Neeraj Buch sir on the certificate. So thank you very much for attending this seminar. More than 100 people are participated in this one. Last remark from our head of the department, Murthy sir. Murthy sir.
Thank you very much for all the participants, and I am very happy for your kind support. All the participants are mailed with your certificates because we are giving the certificate with the signature of the Neeraj Buch sir, our resource person today. And so please don't be panic for the certificates. After getting the digital signatures of the sir, we shall send you the certificates. Thank you one and all for attending the program and their successful completion. Thank you, sir.
Thank you very much. I am closing the meeting. Thank you.